Okay, think about this for a second. What if an AI could see, not just the world as it is right now, but thousands of possible futures every second? And not to tell your fortune, but to stop disasters before they even have a chance to happen. Well, today, we're diving into the story of an AI that's doing just that, swapping out the dashboard for a crystal ball.
So our story kicks off with a number, and it's a big one, over $5,500. Now what is that? Well, that's the insane daily cost to run just one single human-led traffic management crew out in the remote, resource-rich parts of Western Australia. I mean, that's not just a high number. For these companies, it's completely unsustainable. And this slide really just lays it all out, right? You can see the stark contrast between the old way and the new. On one side, you've got these human crews, and it's all high cost, high risk for the people on the ground, and just a revolving door of staff turnover. But then you look at the other side, Sentinel's robot squad. We're talking reduced costs, way better safety because you're taking people out of harm's way, and they can work 24/7. This, right here, is the exact problem Sentinel was built to solve.
So to really get why this whole revolution is happening right now, we need to head down under. We're going to Western Australia, where this perfect storm of economic and regulatory pressure was brewing, creating a crisis that didn't just need a new solution, it demanded one.
Okay, so what exactly was this perfect storm? Well, it was really this trilemma. Three massive problems hitting all at once. First, you've got soaring labor costs. We're talking over $1,700 a day for a two-person crew, and that's before you even start talking about flying them in and putting them up. Second, a critical worker shortage. The entire industry was short over 10,000 workers. You just couldn't find people. And then the knockout punch, tougher safety laws. Main Roads WA came in and said, no more humans in the line of fire on high-speed roads. So think about it. You can't afford them, you can't find them, and now it's not even legal to use them in the most dangerous spots. The old way of doing things, it was officially broken. So, if the old way is broken, how do you fix it? This is where the story gets really clever. Because the solution wasn't just about building a cool robot, it was about this brilliant regulatory hack that completely changed the game.
And this really gets to the heart of the problem they were facing. The laws were written for people. A traffic controller, by its legal definition, had to be a person. So how on earth do you automate a job that, by law, only a human is allowed to do?
The answer, it turns out, was buried in the fine print of those new safety rules. The law required the use of something called a portable traffic control device, a PTCD, on those fast roads. Just, picture a traffic light on a trailer. That's basically it. The law saw this device as the safer alternative to a person.
And here it is. This is the big aha moment. The genius of Sentinel's approach was realizing the humanoid robot isn't a worker. It's not a person at all. Legally, it's classified as a smart PTCD. It's just a very advanced, very mobile piece of equipment holding a stop-slow sign. By reframing the robot as a device, it just sidesteps all the laws written for human workers, and at the same time, it satisfies the new safety rules. Problem solved. Absolutely brilliant.
Okay, but a clever legal strategy and a robot body, that's just the start. The real magic here, Sentinel's secret sauce, is the AI brain powering the whole thing. And this is a huge cognitive shift, moving from a simple dashboard that just shows you what's happening now to a predictive AI that can actually see into the future.
So let's break that down. Most systems out there use what's called a digital twin. It's basically a digital copy of the worksite that shows you what's happening in real time. It's like a history book. It's descriptive, it tells you the facts of the present. But Sentinel uses something way more advanced, a world model. And this isn't just descriptive, it's generative. It gets the laws of physics. It understands things like friction and momentum. So it's not a history book, it's a crystal ball. It's constantly running thousands of simulations of what could happen next.
So how does this crystal ball actually work? Well, it runs on this constant, super fast imagination loop. First, it perceives. It sucks in all the data from cameras and LiDAR to build this live map of the world. Next, it predicts. It generates all these different ways the future might unfold. But here's the crucial part. It simulates. It plays what if 1,000 times a second. What if I wave the sign now? What if the robot steps back? This is what's called counterfactual reasoning. And only after testing all those possibilities does it finally execute the one single action that has the absolute highest chance of a safe outcome.
Now, this AI brain is incredible, right? But it needs a body, or bodies, to actually do things in the real world. So let's meet the hardware. Let's look at the physical team that makes up this autonomous robot squad. All right,
A typical squad has 3 key players, each with a specific job. You've got the hub, which is a Tesla Model Y. It's the command center, providing power, all the computing muscle, and this kind of God's eye view from its cameras. Then you have the Flagger. This is a Unitree H1 humanoid robot, and they chose this form factor for a reason. A human shape instinctively gets a driver's attention. And finally, you have the Scout, a little dog-like robot, a Unitree Go 2. It's constantly patrolling the area, using its LiDAR to keep the AI's map of the world perfectly up to date. The key thing is they don't act alone. They work together like a single coordinated unit.
Okay, so theory is one thing. Let's put this whole system to the test in a real-world emergency. Picture this. You've got a work zone. Speed limit is 60 kilometers an hour. All of a sudden, the system spots a car barreling towards it at 110. A human operator in that situation has maybe a few seconds, if they're lucky, to figure out what to do.
And here's the AI's response. It's superhuman, and it all happens in less than 100 milliseconds. The Tesla's cameras perceive the speeding car. Instantly, the world model predicts a collision is likely in the next 2.5 seconds. The simulation engine then runs hundreds of possible futures. It decides just waving the sign is too slow, too risky, it's not going to cut it. So it executes the action with the best chance of success. It bypasses the robot entirely and automatically blasts the Tesla's air horn and flashes the high beams. It's a faster, smarter, and way safer decision than any human could possibly make under that kind of pressure.
I mean, this is already mind-blowing, but it's just the start. The 5-year vision for this whole platform is even bigger. It's all about scaling human oversight to an exponential degree, leading to a future of almost total autonomy, where the human supervisors become, well, basically invisible.
And this timeline lays out the path perfectly. In 2026, we're starting with a 1-to-1 ratio, 1 human supervisor for every 1 robot squad. Pretty straightforward. But by 2027, as the AI gets smarter and handles more on its own, that 1 supervisor can now manage 3 squads. But here's the real endgame. By 2030, the invisible supervisor. The system will be so autonomous that 1 person, sitting comfortably in a central office somewhere, can oversee 20 or more sites at once. They only have to step in when the AI flags a super rare problem it can't solve on its own. Now that is how you achieve massive scale.
You know, this technology is changing so much more than just traffic management. What it's really proving is that we can build AI that doesn't just react to the world, but actually anticipates it. And it really makes you wonder, right? If an AI can learn the physics of a worksite to predict and prevent a car crash, what other complex systems is it going to learn to predict next? What kind of future will this technology help us build? Safely?